Good morning, grade 12s. In this recording, we will be going through mechanics. So, we're going to be doing physics and we're going to be going through mechanics. Okay. This is meant to kind of be like a really revision session. So, we're going to kind of be going through the definitions of things, to try explain the different concepts. And then we will kind of finish up with going through past papers. We will be working through forces. And going through Newton's law. And then hopefully in the next sessions, we'll carry on with like your work, energy, and power. Okay, cool. So to start off, okay, so to start off, this reads mechanics is concerned with the effect. So mechanics is concerned with the effect of forces on material. Okay, so that's what we're going to be looking at. We're going to be looking at the effect of forces on a material. If you push, if you pull, if if something accelerates, it deaccelerates, what causes it to accelerate, what causes it to deaccelerate, right? So we're going to be looking at the effect of forces on material. That is what mechanics is. Okay, cool. So we're going to start off by going through a couple of terms. Hopefully that you'll be able to under and hopefully if we can go through these terms, you'll be able to better understand stuff. Okay. So the part of mechanics that describe motions without regards to its cause is called kinematics, right? Kinematics, okay? So we're just going to look at different terms, okay? Like I said, this is meant to be a revision session, so I'm going to go through a couple of definitions, try explain a couple of concepts, and hopefully that will help you better understand. Okay, I believe that if you understand some of these, it will help you answer your question papers a bit better. Okay, so this we're going to go through this quite quickly. We're going to start with a couple of definitions, and hopefully, yeah, you can kind of keep up with me. Okay, so we're going to start with position. I'm just going to go through the definitions, maybe a quick explanation. Okay, but this is because it's revisions. I'm going to go through it quite quickly. Okay, so position is, so I'm reading here, I'm not going to underline, so I'm reading quite here. Okay, position is to describe the motion of an object, one must be able to specify its position at all times using convenient coordinate systems. Okay, so position is an example of a vector. It's a physical quantity that has both magnitude and direction. Okay, so it has both magnitude and it has both direction. Okay, compared to a scalar quantity that has only magnitude and no direction. So when we say position, we're like, where is it? Where is the object? And an example, you can say that a particle might be located at x is equals to plus 5 meters because we are positioning it relative to a coordinate system. Okay. Following terminology, displacement. Okay, so displacement, a change from one position x1 to another position, is called displacement. So we said that a particle is located at x is equals to plus 5 degrees, 5 meters. Okay, and then displacement is a change of position. So if it goes from 5 meters to, for example, 10 meters, this distance over here will then be referred to as displacement. It's a change from one position to another position. Okay, and then it's referred to it's written, its formula is delta x is equals to x2, right? 10 minus x1, which is 5. Okay, cool. And then we're gonna go to speed. Okay, so, speed is a different way of describing how fast a particle moves and involves the total distance covered independent of direction. Okay, so it's independent of direction. It doesn't matter where it's going this way or whether it's going that way. It's just we're just concerned about how fast it's going this way or how fast it's going that way, and this then would be the definition of, sorry for that. And this then would be the definition of the formula for speed, right? Speed is equals to total distance over change in time. Okay, cool. Speed is a scalar quantity, and what does scalar quantity means? That it is what does scalar quantity mean? It means that it only has magnitude and no direction. Okay, cool. Because it's independent of the because we just said that it's independent of the direction. Okay, we're just concerned about how fast it's going. Okay, next is acceleration. I think I missed velocity. I think there's also velocity that I missed. There it is. Okay. So then you have something called velocity. Okay. So it says that several quantities are associated with the phrase how fast. Okay. Right now we just spoke about speed. So speed is associated with how fast. We also have velocity, which is also associated with how fast. Okay. One of them is the average velocity, which is the ratio of the displacement that occurs during a particular interval, a particular time interval. It's the same. We're trying to understand that how fast did this car go from here to there, or or how fast did this car go from there to there. Okay, it's independent of the direction. We're really just concerned about how fast is it going. Okay, and this is then the formula of velocity. Okay, it is your displacement over a particular time interval. Okay, a common and then this is also meters per second, scalar quantity, only magnitude, no direction. Okay, cool. We spoke about speed, which is similar. It's also concerned about how fast. And then now we're gonna go over acceleration. Okay, when a particle's velocity changes, okay, the particle is said to accelerate. Okay, so when a particle's velocity changes, the particle is said to accelerate. For motion along an axis, the average acceleration over time is, and this is then the formula for acceleration. So we just say that speed is how fast something is going. So usually it means that it'll be going at a constant speed or a constant velocity. Constant means it's the same. Okay, so for example, if a car is going at 60 kilometers per hour, and here's our car, and it's just going. Okay, it's just going, and it's going at 60 kilometers per hour. The minute it changes from 60 kilometers per hour, now it's going at 100 kilometers per hour. Let's say there's a truck ahead, the car is trying to overtake the truck. Okay, so which means that it's going to go from 60 kilometers per hour to 100 kilometers per hour. There's a change in velocity. Okay, so now it means that we are accelerating. Okay, so that's what acceleration means. It's a change in velocity, and how you calculate it is change in velocity over a specific time interval. Okay, and sometimes with physics, if you truly understand and you understand, like if you understand what it means, you'll be able to also no. I wanted to say in physics, usually the definitions are the formulas, right? The definition of acceleration is change in velocity and over a time interval, and the formula is what? Change of velocity over time interval, literally. Okay, cool. And then, so those were the couple of definitions that I wanted to quickly go over. Very important things to understand. You need to understand what displacement is, what is position, what is velocity, what is acceleration. Just the terminology, right? It's important to be able to understand the terminology. If you don't understand something, grade 12, it's very important that you kind of quickly go to Google and what's this thing? Search the meaning of the word, right? So if you don't understand what proportional means, or you search what it means, so that when you see the word in a definition, they say that something is directly proportional to something, you'll be able to understand the word itself, and then you'll be able to understand the definition. Okay, very important, because like I said, usually the definitions the definitions are the formula. You know what I mean? Like I kind of pointed out with acceleration. Okay, so now we're going to go through a couple of concepts. Okay, we're going to start with free falling objects. Okay, and then we're going to link that to our vertical projectile. Okay, so we're going to start with free falling, and this is when you drop something usually. Okay, so let's say a man is standing at the top of the building, and My man looks like a ball, but you get what I'm saying. So here's our man, he's standing at the top of the buildings and he just drops the ball. And the ball falls and it 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 falls. Okay. The minute he drops it and lets go of it, it starts free falling. It's falling on its own. Okay. So this is where reading. All object dropped near the surface of the earth in the absence of air resistance fall towards the air with the same nearly constant acceleration. Okay, so like my image here, they say that when an object is dropped near the surface of the earth, here is it falling in the absence of air resistance, which is usually the case for all free falling objects, and usually the question paper will kind of let you know that, disregard, your air resistance, disregard your air friction. Okay. They say that it falls with the same it falls with the same constant acceleration. Okay, and we denote the magnitude of our free fall acceleration as g. Okay, so we're going to say that our ball is falling at the speed of g. Okay, we denote, yes, so the magnitude of free falling acceleration decreases when increasing altitude. So they say that magnitude of the free falling acceleration decreases when you increase altitude. So altitude is like if you go higher, we decrease our acceleration. Okay, so free falling acceleration, and we know that the acceleration is approximately 9.6 meters per second. Okay, and this is a vector, and the vector is directed downwards towards the ground. So it's equal to 9.8 downwards. Okay. Free falling is an important example of a straight line motion with constant acceleration. Okay. So that is free falling. Okay. When you drop something down, it's going to fall with a constant velocity. It's going to fall downwards with a constant acceleration of 9.8. Okay. And this is in the absence of air resistance. That's the first concept. Okay. Then in this concept, our acceleration is quite important. Keep that in mind. The acceleration is 9.8. And there's a difference between free falling and projectile, if I'm not mistaken. And I think with free falling, it's that it's being dropped. It's not, there's no initial velocity. Okay. It's at rest, somebody lets go of the ball, drops it. Okay. That is free falling. Okay. And then we're going to go to our projectile motion. Okay. We next consider a special case of two-dimensional motion. So when we spoke about free falling, and when we spoke about the different terminologies, those were all one directional. Those were all concerned with one dimensional motion. Okay, if something is moving from here to here, it's moving what in a straight line. It's a one dimensional. I think it's dimensional. I don't know if it's directional. Let me quickly confirm. Yeah, it's dimensional. So it's a one dimensional motion. Okay. And then if you speak about its displacement in a one-dimensional motion. Okay, even with free falling, they say that free falling is a straight line motion, a straight line, one-dimensional. Okay, so they say that we next consider a special case of a two-dimensional motion. A particle moves in the vertical plane with some initial velocity, but its acceleration is always the free fall acceleration, which is downwards. So now we have it's now we have this, which is two-dimensional. Okay, it moves in a vertical plane with some initial velocity, right? Like I said, free fall, the initial velocity is zero, but with my projectile, there is some initial velocity. Okay, so here we have some initial velocity, something is projected, it gets to a point where it's zero, and then at this point, from this point on, it starts free falling. Okay, so there's a projectile, there's a projected part of it. Okay, so they say such motion is called projectile motion. Okay. Okay, yeah, that's it. Okay, so that is our projectile motion. It's when there is initial velocity, um, there's initial velocity where something then is projected, right? Moves all the way up, gets to a point where the velocity is zero, then it starts being a free fall object, and then its acceleration, and then it's always then it starts free falling, and then now we start looking at it as a free fall object with the free fall acceleration, which is downwards. Okay, I hope that makes sense. So we spoke about free fall. Now we're speaking about projectile. I hope the projectile makes sense and you understand the difference between the two. Okay. Okay. So that was that. Okay. And when we spoke about all of these, we hadn't considered force. Okay. So when we spoke about displacement and we spoke about free falling and all of that, we hadn't considered force. Okay. Free falling and your projectile was being about an acceleration and stuff like that. So now we're gonna just speak about the concept of force. Okay. So classical so it says right here that classically, mechanics describes the relationship between the motion of the object and the force acting on it. I really feel like if you fully understand these things, it'll be easy to go about answering the question. So we're looking at the relationship between the motion of the object and the forces acting on it, right? Okay. And there are conditions, correct? There are conditions in which classical mechanics does not apply, and the conditions in which it does apply. Okay, so we can look at the concept of force. Okay, I'm going to quickly go through the couple of forces. Okay, so the concept of force is an interaction. So I'm reading right here. So force is an interaction that can cause deformation or change of motion. Okay, so force is an interaction that can cause deformation or change of motion of an object. Okay, I said it's very important that if you see a word you don't understand what it means, that you kind of quickly go search what the meaning of the word means. Okay, so the meaning of deformation, let me quickly say in physics so that we know. Deformation, it's the transformation of a body. Okay, transformation of a body from a reference convert. Oh, it's a change in size. So deformation just means change in size. Okay, so that's all deformation means. Okay, so deformation is a change in size. Okay, so now I know what it means. So it says that this force can cause deformation. It can change the size of something and or right change the motion of an object. Okay, so we don't necessarily kind of focus on the deformation part. We usually focus on the change of motion, and that means this force can cause an object to go from rest to motion, right? So which means that maybe this ball was standing still. Somebody then kicks the ball. My feet look quite horrible, but you get what I mean. So somebody then might kick the ball, and then the ball starts moving. Okay, the ball might already be moving at a constant velocity. Somebody kicks it again, so then and then it goes from constant velocity, then it starts to accelerate. So that's what we're going to be looking at, right? The change of motion of an object. Okay, so it says here, force is a vector quantity, right? So fundamental. So force is a vector quantity. What does vector quantity mean? It means that it has both magnitude and it has both direction. Cool. Okay. Fundamental forces are, so we have a couple of fundamental forces, but I want us to go through, okay, these are some of the fundamental forces. We're going to go through the forces along the slides, right, individually. So here are some fundamental forces. Okay, here we're reading right here. We have gravitational, electromagnetic, weak nuclear, and strong nuclear. Okay, so our fundamental force in mechanics, we're just going to be looking at gravitational, and I think in some of your other topics, you also go through your electromagnetic. Okay, your nuclear, strong nuclear, weak nuclear, we're not going to be dealing with that. Okay, cool. So that is force, right? It's a force. It's the interaction that causes deformation and or change of object. That's what force is. And our fundamental force is gravitational force. Okay. I think if we continue here, we will go through our forces. I just want to quickly make sure that we do. I don't know if I missed it. I think I did. How? Let me just quickly. I'm trying to understand because we are meant to go through the forces individually, which is what I really want us to go through. This is quite interesting. Now we're going into Newton's law. Yes, there it is. I've got it. Okay. Because yes, I want us to speak about the forces. Then we're gonna go through some particular forces, and then we'll go back to Newton. So I don't want to confuse us. Okay, cool. Yeah. So this is where we're gonna start off. Okay, so we have forces. They cause a change in motion, and now we're gonna go through some particular forces. Okay, so I want this to become your checklist. Okay, so this becomes your checklist when you are drawing your free body diagram. Okay, so this is going to become our checklist when we're drawing our free body diagram. Okay, so we're going to kind of see if these forces apply in the different questions that we're going to be going through. Okay, we're going to start off with our gravitational force and weight. Okay, quickly going through this. It says that the force exerted by the earth, so this is what I'm reading. It says the force exerted by the earth on an object is our gravitational force. Quick, that's it. Okay, so and this is it's trying to keep us on the earth. It's pulling us downwards, right, towards the center. It's pulling us towards the center of the earth. Okay, so here, all right, now this is where we're trying to understand weight and trying to understand gravitational force. Okay, it says that the magnitude of gravitational force is called weight. Okay, the magnitude of our gravitational force is equals to weight, right? So our gravitational force is equal to the weight. That's the magnitude of it. Okay, so gravitational force weight is equals to gravitational force, which is mass times gravitational acceleration. Okay, g is the magnitude of our free fall acceleration. Okay, weight is not inherent is not an inherent property of an object. Okay, so we don't say this has we consider gravitational force, and then the magnitude of the gravitational force is called weight. Okay, I hope that it makes sense, right? So if I say the gravitational force is, for example, 50, right, Newton. If I'm saying this is the weight, 50 newtons is the weight, okay? Because it's the magnitude of gravitational force. Okay, I hope I'm making sense, right? Okay, the next one in our checklist is the normal force, right? So the normal force, they say that if you stand on a mattress, Earth pulls you downwards. So you're standing on a mattress. Here you are. No, I think you're fine just like this. You're standing on a mattress. They say the Earth is trying to pull you downwards, but you're stationary. You don't feel it. You're not being physically pulled downwards. They say the reason is that the mattress, because it deforms, pushes on you. Okay, pushes on you. This force from the mattress is called your normal force. Okay, normal force is perpendicular to the surface. It's very important to understand that it's perpendicular to a surface. Keyword surface. Okay, if there's no surface, if something is floating, if something is swinging, if there is no surface, so there is, there isn't anything that pushes back up on you. That surface, right, that is pushing back up on you, then there is no normal force. Okay, but then they say that's the definition of your normal force. Okay, hope that makes sense. Okay, so checklist, gravitational force. Second in the checklist, normal force. Then we're going to speak about our frictional force. Okay, they say that if we slide, so I'm reading right here, if we slide or attempt to slide a body over the surface, the motion is resisted, okay, by a bonding between the body and the surface, right? And the resistance is considered to be a single force called our frictional force, okay? This force is very important in our everyday lives. This allows us to walk and. But they say that this force, this is what I want to go over, the frictional force is directed along the surface. Okay, so frictional force is directed along the surface and in the opposite direction of the intended motion. Okay, so if something is going this way, this is the direction of motion, then our frictional force will be in the opposite direction. Okay, and our frictional force will be in the opposite direction. Then this will be our frictional force. Okay, cool. So for an object in motion, the frictional force we call our kinetic frictional force. Otherwise, we have our static frictional force. Okay. And then we have coefficients. So it says both kinetic and static frictional forces are proportional to the normal force. Okay. They are proportional to the normal force acting on the object. I said that it's very important that we kind of go over the definitions of things. So let's quickly go over proportional. Proportional. Okay, I had searched it the other day. So some quantities depend upon another one, and such quantities are termed as proportional. Okay, but I'm looking just for the word proportional. So the word proportional means corresponding in size, degree, or intensity. It's corresponding. Okay, so I don't know if I'll be able to, I hope I'll be able to paste. There we go. I am able to paste it. Just give me a moment. I'm just trying to make it smaller. Okay, so proportional is when something is corresponding in size, degree, or motion. It's corresponding to this, and it's corresponding. Okay, let me quickly. It's corresponding, right, in size, corresponding in size, degree, or intensity. So when they say that our static frictional force are proportional to our normal force, it means that they are corresponding in size, right? So that's why our frictional force is equals to the coefficient as well as our normal force, because they're corresponding in size. Okay, so that's what proportional means. So then you have our static frictional force, it's the coefficient times your normal force, or your kinetic frictional force, which is your coefficient times your normal force. Okay, that is the third thing that we're adding is our frictional force in our checklist. Okay. Moving on, we have tension. Okay. So now this is where we add with tension. It says that when a cord is attached to an object and pulled, right? The cord pulls on the object with the force Ft called tension. The force is directed away from the object and along the cord. So it says that if you attach a cord to an object, so we've attached this cord to an object and we pull, they say that there is going to be tensional force along the cord, right? It says along the cord and away from the object. So there's tensional force along the cord and away from the object. So there's tensional force along the cord, away from the object. So that is our tensional force. And then our last force is then the spring force. Okay, a good approximation from many springs. The force from a spring is proportional to the displacement. It's corresponding in size. Okay, and the free end of it's corresponding. It's proportional to the distance. This is what I'm reading. So it says spring is proportional to the displacement of the free end from its position when the spring is in the released state. Okay, so it's proportional to the displacement of the free end from its position where the spring is released. Okay, So this is also known as your Hooke law. I think that's you can kind of go back over it and revise over that law. This is how you calculate the force, and then they say K is a constant. It means the stiffness of the spring. The larger, they say the larger the K, the stiffer the spring. And yeah, that is our spring force. That's the last force. Okay, so which means that when we're drawing our free body diagram, we're going to have to consider the following. We're going to have to look, is there gravitational force? Yes, no. Is there normal force? Yes, no. Is there frictional force? Yes, no. Is there tensional force? Yes, no. And is there our spring force? Okay, seems like spring force is just, it's just F. Let me put an S. Okay, that's going to be our definition. Okay, I'm going to quickly go over Newton's law quickly, and then we're going to hopefully do a question or two. Okay, so then you have Newton's law. Okay, so before Newton, no, no, yeah, then you have Newton's law. Okay, so this is it's speaking about motion. Okay, Newton's laws are related to motion. Okay, so Newton's first law of motion, so this is where we add Newton's first law of motion, states that an object at rest remains at rest, or an object in motion continues in motion until constant velocity with constant velocity unless it experiences a net external force. Quite straightforward. If a box is sitting still, it's going to sit still. Or if a car is moving at a constant velocity of 60 kilometers per hour, it's going to constantly move at 60 kilometers per hour unless a net external force is applied on the object. Okay, so unless we apply net external force on the object, unless we apply F net on the object, then it won't be stationary more because I'm trying to push it, so it's going to move, right? It's gonna wanna move, right? And then if we kind of, because on the pedals, I'm trying to draw it, okay? Because on the pedals, this is a foot. If you're driving and you're driving at a constant velocity, you have your foot stationary at a specific angle. Okay, this is the bottom of the car. Okay, you have your foot like it's on the pedal at a specific angle and it's there. We what am I trying to say? I'm trying to say that you've placed it at a specific angle on the pedal and you're leaving it there, right? The minute I press down on my accelerator, right? So this foot is pressing down on the accelerator. What am I doing? I'm exerting external force, and that means that I'm exerting external force. So that means it's going to accelerate. It's no more moving at a constant velocity. That's what Newton's first law mean. Okay, what's very important to consider here, Newton's first law says that when the net force of an object is zero, the acceleration is zero. Okay, I'm going to quickly go over Newton's second law. So Newton's second law, so this is where we're at, and this is what I'm reading. The net force of an object, okay? So now Newton's second law explains what happens to an object when the net force is acting on it. That's Newton's first law, right? Newton's first law explains what happens when the net force acting on an object is zero. Newton's second law answers the question what happens to an object when the non-zero force act when that has no. Newton's first law, net force acting on it, zero. Now Newton's second law explains what happens when there's an actual net force acting on the object. It's not zero anymore. Okay, so then it says that the net force of the body is equal to the product of the body's mass as well as the acceleration. And it goes back to, and I want to kind of reinforce the fact that if you know your definition, you can score yourself 2 marks. But if you know your definitions, you'll be able to also know the formulas. With physics, definition is associated with your formula, and it's very important, right? It's because then you know, okay, we speak about Newton's second law. What is the formula associated with Newton's second law? It's that from definition, the body of the masses, it's equal to the product, right, of the body's mass. Product is multiplication, and the acceleration, right? Know your formula, know your definitions, you'll be able to remember your formulas. Okay. Know your formulas, you'll be able to kind of what? Know your definitions. Because what it says, it's literally saying that net force is equals to the product of your mass multiply your acceleration. Great. That is Newton's second law. Okay. There's now, so with Newton's second law, we have an external force and we have acceleration. Okay. Newton's first law, zero external force, zero acceleration. Okay, cool. We are now going to go to the last one, which is Newton's third law. Okay. So with Newton's third law, a force is exerted on an object. A force, this is what I'm reading, a force is exerted on an object when that object comes in contact with some other object. Okay. A force is exerted, right, when the object on a force is exerted on an object when that object comes into contact with another object. There's a force that's going to be exerted. Okay, so Newton's third law reads that when two objects interact, the force from each other are always equal in magnitude, but what? Opposite in direction. Okay, so when these kind of interact, this is going to exert a force on this one, this is going to exert a force on that one, and it's equal. It's going to exert equal forces, forces that are equal in magnitude but opposite in direction. Okay, then that's it. Okay, that is our Newton's laws and that is our different forces. Very, very important. You guys really have to practice this. It has to become almost like second nature. The fact how to deal with forces at an angle. Okay, so if you have a force that is acting, let me do it this way. Let's say I have a force here, an object here, and I have this force over here, and I'm saying, let me shoot up, and I'm saying it's acting at 45 degrees. Okay, I'll quickly do it. I know that please, please, please work on how to resolve your forces. Okay. I know that if this force has both a force in the x and a force in the y. Okay. And know that it's gonna be this way because we always have a head to tail relationship. The head of the other force needs to meet to the tail of the other force. The head of the other force needs to meet to the tail of the other force. Now work from this one. So if I know this is head, this has to be tail. And if this is tail, if this is head, it's gonna have to be tail. Simple. Okay. And then we work with our trigonometry. So if I know this is 45, so what is this force? Okay, so we have Fx and we have Fy. Okay, Fx, we know that here, when we're dealing with this force, we have adjacent over hypotenuse, so adjacent over hypotenuse, and that is our cos theta. Okay, so I know that cos theta is equals to Fx over F. Okay, and if I'm looking for Fx, then I know that Fx is equals to F cos theta, right? And then I'll know that my Fy will be equals to sine F sine theta. This is very important. If this doesn't make sense, there's resources, kind of really work on resolving your forces. So then it becomes second nature that, okay, I'm going to resolve this. This means that there's a force acting here. This force is a force here, and there's a force here, okay, which is this force. Okay, cool. I'm going to quickly go over a past paper. Let me see. I don't know what page it is for this one. Nope. Maybe 6. Okay. Okay, cool. So, I'm just gonna quickly go over this. Okay. Um, yeah, I'm going to quickly go over question one. Okay. So this is, let me quickly go over the first page. So this is an Eastern Cape 2022, September 2022 paper. Okay. Eastern Cape, September 2022. If you search, great. If you, it's downloadable. So if you search past papers and you look specifically for the Eastern Cape one, you'll be able to find it. Okay. I can share it always, and I'm proud of doing that. Okay. And then we're working with, what's this thing? Question two. Okay. Question two reads, so I'm reading over here. Okay. I think a tip is you usually have a diagram. So sometimes you can add things to the diagram so that you don't always have to go back and read this whole paragraph again. Or you can underline things so that you don't forget. Okay. So that's like a quick tip. Two boxes of masses, 3 kilogram and 8 kilogram respectively, are connected by a light extensible spring as shown in the diagram below. So we already have it in our diagram. And what's great, they're telling us this is the 3 kilogram and this is the 8 kilogram block. Okay. And this is then the spray, the light string that is, connecting the two. Okay. They say the spring moves over a frictionless pulley. So I know that this pulley has no friction. Okay. So I know that the friction here at the pulley system is equals to 0. Okay. And then it reads, the spring moves over a frictionless pulley, and the 3 kilogram is placed on an inclined plane at an angle of 30 degrees to the horizontal. So it's already given here. It's inclined at a 30 degrees angle. Okay. A force. There it is. Here's our force. This will be our FA, our applied force. A force of 55, which makes a force of 55 newtons, which makes an angle of 15 degrees with the horizontal, is applied to the 8 kilogram block to move the system of the block to the right. Okay, so then I can also then do this, and this could be then my direction of motion. Okay, and I'm going to say this is my direction of motion. Okay, which is right, to the right. Okay, cool. Um, yeah, to the right. Okay, 3 kilogram block experiences a constant friction of 5 newtons. So I know that if, what am I trying to do? Yes. So I know that if the 55 kilonewtons causes our 8 kilogram newton to move to the right, this is connected. So this is also going to move this way to the right. Okay. I know that my frictional force is in the opposite direction. Okay. Then this is my frictional force. Then I can write it down here and say if friction is equal to 5 kilonewtons. Okay, the coefficient of our kinetic friction between the 8 kilogram and the surface is 0.8. Same here. This is moving this way. So I know that this is moving this way, right? Which means that my frictional force is moving in the opposite direction. It's moving this way. Okay. Then I know that my F friction is equals to 0.16 times what? Times our normal force. Okay, so this is what I mean. I'm saying read the information, and if it's not shown in the diagram, add it. So then I don't have to reread this. I've read it, okay, and I've added all the information. I've added the fact that this is frictionless in the pulley system. I've added the fact that I can see that it's at an incline. I can see that there's an applied force, and the force is at and the force makes an angle of 15 degrees. So it's pulled at an angle. Okay, I get the direction. Write all of this information. Okay, so then we have first question definitions. Always state Newton's law of motion in words. Okay, what did I say? I say if you can remember the formula, you'll be able to define it. If you can define it, you'll be able to remember the formula. So I know that the formula of my Newton's second law is F net, right, is equals to ma. So that means that from this, I can define it. Okay, so I can define Newton's second law. So I can then say Newton's second law No, let me not write Newton's second law. Okay. I can then define it. Then I can say that Newton's second law states that the net force is equal to the product to the is equal to the product of the object's masses, object mass, and acceleration. Wait, accelerate. Okay, this then becomes our definition. Okay, net force is equal to the product of the object's mass and acceleration. That's it. 2 marks. Okay. I just want to quickly make sure that it's correct. I don't want to give you guys the wrong things. Yes. Net force of a body is equal to the product of the body's masses and the acceleration of the body. So they say body here. I'm going to quickly fix my definitions because I said I said object and they say body. Okay. Just the page before. Come on. Where is it? Okay, there it is. Oh. Okay, so what did I say? Oh, wait. There it is. I'm just going to fix this. Okay, so its net force is equal to the product of the bodies, mass and acceleration. Oh, why am I spelling acceleration wrong? Accelerate. Acceleration. There it is. Okay, that's my definition. Here's my formula. So then it says draw a free body diagram of all forces acting on the 8 kilogram block, 5 marks. So what did I say? I said that we're gonna then go over what's this? We're going to go over our checklist, okay? How to draw a free body diagram. Your object becomes a dot. So there's my dot, and then all the forces acting on it. Then we draw all the forces acting on this object, which is our dot over here. Okay, let me do it here and do it here. Okay, so here's my 8 kilogram newtons. I go over my checklist. Okay, is there gravitational force? Yes, there's gravitational force. So then it's acting downwards. Okay, this is my dot has become quite. My dot has disappeared. Let me make it in red. I can't see it anymore. And it's not visible. Okay, there it is. Okay. Is there gravitational force? Yes, there's gravitational force. Is there normal force? Yes, there is. This is sitting on a surface, and there's going to be perpendicular force that is exerted by the surface to the 8 kilogram block. So yes, there is normal force. Okay. Is there frictional force? Yes, and I know that there's frictional force. I've already drawn it out. Super cool. So then there's my frictional force. Is there tensional force? No, there isn't tensional force. There isn't a cord, right? There isn't I'm lying. There is a spring. Here's this. There's the spring. Okay, so we know that tensional force is exerted along the spring, okay, away from the object. Okay, so we have also this. This becomes our tensional force. Okay, yes, there's tensional force. And then there's also applied force. So we have this over here, which is our FA. Okay, is there spring force? No, there's no spring, so there is no spring force. Okay, I've gone over my checklist. I can count 1, 2, 3, 4. 1, 2, 3, 4, 5. I have 5 forces. This is 5 marks. I'll probably have all the forces. Okay, so then it says calculate the kinetic frictional force that the 8 kilogram experiences. So now we're going to speak about how then do we tackle the questions. Okay, I'm going to try and move this a bit upwards. Okay, how then do you try kind of tackle the different questions? Okay. So they say that a kinetic force, a kinetic frictional calculate. So now we're looking for our kinetic frictional force. That's the unknown. Okay. So we're looking for our kinetic frictional force. I don't know how to write it. Fk. Okay. So this is what we're looking for, and I know that Fk is equals to 0.16 multiplied by my Fn. this is what I'm looking for. Okay. Um, yeah, this is what I'm looking for. Okay. So I have two unknowns, right? I'm looking for my kinetic frictional force, but also don't know my normal force. So what do I need to do? I need to calculate my normal force. That's the first thing that I need to do. Because once I have my normal force, I'll be able to calculate my kinetic force. My, what's this thing? Yes, I'll be able to calculate my kinetic frictional force. Okay. So then it's like, how then do I calculate my kinetic force? Okay. How do I calculate my kinetic? How do I calculate my bad? I'm sorry. How do I calculate my normal force? Because I'm looking for my normal force. Okay. So I'm gonna focus now. So I'm looking for this, and to get that, I need to first find this. Okay. So then I'm looking first for my normal force. How do I calculate my normal force? I can look at all those sum of forces acting in the y direction. Okay. So I can do that. Okay. So then I told you guys need to be able to resolve your forces, then because you're able to know that in this case I have a force. Let me do it in a different color quickly. Then I'll know that, okay, I have a force here and I have a force here. If this is head, this is tail. So this is going this way and this is going that way. Okay. And I know that this then becomes, it's equals to, this is equals to your F sine 15. I wrote it. I don't have space. This is my F sine 15 degrees. Okay. So I have all my sum of forces in the y direction, right? So then I know that I have, I'm going to take up, yes, so I'm going to say sum of forces in the y direction, I'm going to take up as positive. Okay. I have, what's this thing? I have Fn plus minus, I know that Fg is equals to m times g, so minus m times g. This is going downwards, minus f sine theta. Okay, we're just looking for Fn, so I know that Fn, I think this is equals to 0. Fn will then be equals to, I take everything to the other side, mg plus f sine theta. Okay, and then I'm just going to replace it here. So then I know that it's equals to 0.16 multiplied by my mg plus f sine theta. Okay, do I know what my mass is? Yes. I know what my mass is, I know what my gravitational acceleration is, I know my force, and I know my angle. So then I'm gonna kind of fill everything in, and then I'm gonna have my answer. Okay. And then it says calculate the tension in the string. So now we're looking for tension. Okay. So with tension here, which is over here, so we're looking for this tension. I now have this frictional force. I know what this value is. Okay, I know what if, and I know, yes, I know my frictional force. So I'm looking for tension. Okay, so if I say sum of forces, let me do it in a different color maybe. So now we're looking for tension. Okay, so now we're looking for tension. Sorry, guys. Okay, so now we're looking for tension. So I know that F net is equals to MA, right? Okay, so F net is equals to MA. I know F net, which are all of these. Where am I? What happened to my forces? Wait, what happened to my free body diagram? I think I deleted my free body diagram. Okay, I had a free body diagram. I can't see it anymore. Okay, it's fine. Um, that's weird. Um, but we had if friction, if tension, and as well as if cos theta. Okay, so those are all my if net. So then I have what? I'm gonna take the right as positive. So we have if, let me do it down here. Let me do it down here. So we have if sine theta minus tension minus our frictional force is equals to ma. We calculated our frictional force. We know what this is. So we're looking for tension. But now I know what the mass is. I don't know what the acceleration is. So I have so now I need to find first my acceleration to find out what my tension is. So, but then how do I, or do I have to find my acceleration? Those are the questions you need to ask yourself. How do you get this? Okay. You can quickly take the time and understand how would you go about answering this question. But then now I know that this has tension, but I know that I have another block over here and it also has tension, okay, over here, right? So then I can create a free body diagram for my 3 kilogram. Let me do it. So we'd have our normal, our gravitational, then you'd have your um it's moving this way, so you have your tension, okay, and then you have your frictional force. So and so here is the plane. So this is at 15, it's at 15 degrees. And we have all of these things acting on it, okay, at an angle, okay? So I know that T minus F is equals to F parallel for this force. So I know for my this is for my 8 kilogram, and this is then for my 3 kilogram block. I know for my 3 kilogram, tension minus frictional force is equals to, no, not equals to, minus my F parallel is equals to MA. Okay, so now I have MA here, I have MA here, I have tension here, I have tension here. I can make, what's this thing? I can make my acceleration the formula of my, no, I can make tension because it's an unknown. I can make tension the formula of I can make tension here, the formula of this. Yeah, I can make tension, okay? What's the word? Not the formula of like, I can say tension is, I'm forgetting the terminology. Not the formula of the equation, like the head of the equation. Okay, I'm forgetting the terminology, but I'm gonna make tension. I'm gonna calculate. I'm forgetting. I'm mad that I'm forgetting the terminology, but I'm gonna say tension is equals to that, and I'm gonna say tension is equals to that. Okay, this tension here and this tension here is gonna be the same. Then I'll be able to then say this. Then 1 will be equals to 2. Then I'm going to say 1 is equals to 2. They both have the same unknown, which is acceleration. I'll be able to calculate the acceleration. Okay. And then once I have the acceleration, I can either put it back in equation A or in equation 2 to calculate tension. Okay. I hope that makes sense. Okay. We don't have a lot of time. The time is almost done. I think next time we'll move over and do vertical projectile, and then maybe quickly define work, right? Quickly define work energy. No, it's not work. Quickly define work work, energy, and power, and maybe also do this question. Okay. Yeah, that's it for today.